So if you are on GitHub, you actually leak your public key, your SH key, to anybody by default. So if you ever register an SH key at GitHub, go to github.com/my_hd.keys, you get my public key for SH. Well, I mean, that doesn't really seem like a big deal, except for you can use that SH key to then find out which server on the internet accepts that user. So I can now take your key, do a half authentication against it, and say, like, does, server1.apollo.networks.com allow this public key for this username? And so you can both take one key and try it against a bunch of servers. You can also take a ton of keys, like dump all 117 million GitHub pub keys, and then throw them all at one computer and see which GitHub users have access to that computer. So the most useful thing for this is to dock somebody. Like when Antone did the backdoor for executils, we took Antone's pub key, scanned the entire internet, seeing which ones accept authentication, and then accidentally found a bunch of shells instead. But you can use this to also figure out, like, okay, I want to rotate the pub key that I use for my internal network. Take your old pub key, scan the network for it, and figure out which ones still accept that key without having to have the private key. So that's a cool thing. You can actually do like this half authentication at stage without having the private key side of it. Another fun target, of course, is VPN appliances. These were the number one way people broke in according to Bandit last year. They broke in through your security products. So Palo Alto, Avanti, and Fortinet were the easiest ways into most corporate networks last year. And there's an awesome tool called Nuclei, all supported project discovery, also written in Go, that's fantastic. And you basically just give it a bunch of tags, give it a target, and just sprays attacks at it and tells you what it can do and what it can't do. So really, if you're used to like vuln scanners like Tenable, Nuclei is much better, much faster, and very specific for web. Yes, sir?
When you say scan the public internet, like you go through the list of all public IPv4 addresses, IPv6,
Yeah.
or do you have a database?
Yeah.
Just that, go through the list of all possible IPv4 addresses?
Yeah, it takes about 25 minutes to do one port.
Okay.
You just go in DigitalOcean, you get like a big honking machine with 16 cores. There's one of the you can either just do all of IPv4 and subtract like 223.0 and all the reserve ranges, or a fast way to do it is go to bgp.tools and you download their current CIDR advertisement list from BGP, and you only scan those subnets because that way it avoids all the unadvertised space.
So actually accessible through the BGP. Okay.
Yeah. So there's usually about Constantine.
No, isn't it against like their TOS to scan like other networks?
You give them lots of money and scan things from them all the time, they don't seem to care. So no, DigitalOcean is actually my favorite because they don't do stupid packet limits. If you try to do like fast scanning off like AWS, you'll hit like 3 different types of shadow limits before you get the packets out. If you enable any kind of security groups whatsoever, then your connection tracking is enabled at your instance. You can only do up to like 1,000 connections and things start to break. There's all these stupid limits in AWS, and then providers like OVH, Hetzner, and Linode will all shut you down for abuse.
Yeah, I think that's what I've heard.
Yeah, but don't use them. So you use DigitalOcean, and the great thing is if you scan fast enough, by the time they complain, you've already turned the server off. So problem solved. They say you're scanning, like, okay, sorry, I solved it.
So you basically get more privacy by being on IPv6 only.
Yes, unless there's a kind of cap to that. So, is anyone familiar with Shodan? So Shodan.io, they scan the whole internet constantly, and they have a really dirty trick for IPv6 discovery. So V6 is really hard because basically every machine gets the internet times internet of IPv4 space to itself, /64. So how do you find a V6 address? Well, unless it's talking to you or it has a DNS record, you're not going to find it, right? So what Shodan does is a really dirty trick. They register. Is anyone familiar with NTP? The time protocol. So NTP is like a community thing. You can like register your own NTP servers, hook up to a GPS, provide timed internet, all that fun stuff. So Shodan runs a ton of NTP servers, and they register all the pools. And whenever your IPv6 machine does an NTP lookup, it'll round robin, hit one of their NTP servers. They see a connection from a new IPv6 address, they scan you right away and put it on the website. So if you look at Shodan.io and you do a search for has V6 true.
Is this legal?
But the cool thing about Shodan actually has like 250 million V6 addresses in their database at a given time, which is way more than even the academic research projects like the V6 hit list or IPv6.
Do they monetize it?
Yeah, I paid them lots of money to get it.
Okay.
And you can also just browse to it for free, but like I pay them an OEM license, download all their data because it's useful.
Okay, cool.
So, but and John Mapley, the guy who runs it, is actually here in town, just north of here. So, really nice guy, really cool project. So yeah, a lot of stuff is kind of hackery focused, but Shodan, of course, has some unique things to do searches on V6, etc. Like here's an example of V6. So if you search Shodan for IPv6, there's actually 124 million V6 addresses right now. And the little chart shows you they went from like very, very few at all to them deploying their NTP thingy, and also they get tons of V6 addresses afterwards. So you see actually in their own charts when they deploy their V6 sniffer thing. So once you start like getting into a network, you start looking for other things you can do. This is where like Responder and Flamingo are actually useful on internal networks. So the idea is you want to just set up a listener on your machine that listens to port 22, 161 for SNMP, SMB, all that kind of fun stuff, and you just wait. And what's happening is, in the background, the customers are typically running all these tools in the background, like your vulnerability scanner. So if you're using Tenable or Qualys or something like that, it's going to try to do an authenticated scan every computer on the network, including you. And once it's authenticated scan you say thank you for the password and director, and then you go hack everything with their password from their vault scanner. So that's one of the main reasons you don't want to do authenticated scanning, because you're giving every IP on the network your password as part of the authenticated scanner. And while there's ways to mitigate the risk, nobody does. Like typically the credential you get from a Tenable is something you can then easily replay. And SNMP is an easy one too, because V2 communities are clear text. If you get like the super long random password for SB monitoring for a switch, you can then monitor all their stuff, find all their stuff, enumerate it, etc. And even better, if you get the private SNMP string, you can then rewrite the configuration of Cisco and things like that through the private SNMP. So Flamingo is a tool that we're working on to do that. It supports SNMP and a bunch of other things. And basically you just sit there and hang out and listen to stuff and get free data, which is nice. There's another tool that I like to play with, which is the thing called NextNet. It's a little Go utility that does NetBIOS, UDP. And NetBIOS is a cool trick where if you ask a computer for, or you ask the computer for its name, it'll come back saying, my name is X for NetBIOS. But if you go back to that same computer and say, what are the IP addresses for this name? It'll come back and list all its IP addresses, even the ones that are not the ones you know about. So if you've got a computer that's on like the Wi-Fi and on Ethernet, or it's got a VPN adapter or something like that, and it's running Windows and NetBIOS, you can just ask the computer, what are your other IP addresses, unauthenticated over the network with UDP, and you'll get this all back from this tool called NextNet, which also go the source, etc. So the neat thing about that is that you can say which computers in this network will let me go from the network I'm on now, like Wi-Fi, to a wired network, or to a PCI CDE, or something more sensitive than where you currently are. And this tool is a really good example of just writing a little quick UDP scanner, so you can for like a framework for doing UDP probing of some sort. Some of the fun tools are RPC document packet, and then the OXI2 resolver stuff, which is a similar thing you can do with DCRPC. I'm actually looking at porting over the DCRPC stack from Go exec and Go DCRPC, Go MSRPC into some of these other tools as well. So you can do all the stuff from Go and sometimes it falls back to Python for it. And that's great, let me tell you that. Let's see. Nuclei is also awesome. So you can go through and do a lot of control scanning, targeting, etc. There's a category of things in Nuclei. All they do is check what technologies are running. So you can run like dash tag each of these technologies, and give a list of all like the Jenkins servers that work, all the different products, all the different storage things. It's a really great way to do quick inventory based on web interfaces. One of my favorite targets are these little like key value databases like etcd, console, Redis, etc. Because typically you can find tons of credentials in them, and then people leave them exposed all the time. Mostly because developers leave them exposed because it's on by default. You run a Docker, you don't think about it, you miss an ACL, etc. So it's very easy to accidentally expose these to the network, and they usually are full of good juicy things. There's a really funny bug that happened because Mongo is a greedy. Mongo is a terrible company. So Mongo decided that they were no longer open source a long time ago. They also said that they don't want to be benchmarked unless it's their specific binaries. So they only give you binaries that they build, and it's legal, against the contract language for you to build your own binaries because it, goes against their whole thing. And the reason they brought it up is because, we don't want people running things on slow CPUs. That's getting benchmarked on a crappy CPU and not being able to use their current optimizations like that. The horrible part about this is that because they added a ATX requirement to the CPU build, so they said we will only run newer versions of Mongo on a CPU newer than Sandy Bridge, I believe. Same for ARM, it requires ARM 8.2 and newer. So what happened is after Mongo 5.0, 5.0 requires a newer CPU. So what happens if you're running a product or you're running a tool and you have to have Mongo? Well, you don't get newer versions of Mongo. So if you take the absolute latest version of Ubiquiti Unify, the home Wi-Fi management tool, or the absolute latest version of Cisco ICE, a very expensive enterprise tool, they both ship with Mongo 4.2 and 4.4, which is now like 8 years outdated for vulnerabilities, because they literally cannot run it on a machine with older CPU. And because they're using a virtual machine, they can't control the CPU you're running on. So they have to basically fall back to using ancient version of Mongo because you literally can't get a binary for it. So it's one of the major pains in the butt for Unify right now. If you're running Unify stack on like your own VM or running the Unify OS stuff, you're basically stuck with an ancient version of Mongo because they're greedy and won't give you a binary from older CPU. They're basically pulling down the security of everybody who embeds Mongo as a result. So kind of a nasty side effect of their kind of hubris. We won't go too much. We can do like fun log script hacking. You can also take over patch management systems and mess with those. You can basically beat up the really old computers. So if you can figure out which machines are the oldest on the network, those are going to be your best bets in half the time, because usually very few of them. And if a computer's been around for 10 years and someone hasn't replaced it, there's probably a really good reason for it. It's probably really important. It's probably like running some database that no one else does. Probably running your door access control system. So the older something is in the network, the more likely it is to be valuable after it's about 3 or 4 years old. So the way you can look it up based on MAC addresses. I run a project based on MAC addresses, how old the computer is based on when the MAC was registered, and it works for pretty much all the newer registrations. You can look for copyright strings, you can look for really old ASCII modified headers, legacy OS, and you can look for like old TCP/IP services like charge-in that are typically not present on newer machines. And these are all great because these tend to be end-of-life machines, and you have a bunch of known vulnerabilities for them, and they're sitting on important things, otherwise they wouldn't be there anymore. And lastly, of course, printers are awesome. So if you find a printer, there's a million things to do with it. One of the really funny things recently, this is also related to Go. So there's this Brother printer, which are one of the few printers that don't try to gouge you on print or ink and things like that. It doesn't require a cloud license to print your own damn paper. So people like Brother printers because they're not innovative, they don't do shit, they just print. That's what we want my printer to do, just sit there and print things. So the state of California made it illegal to have a default password in consumer electronics. And it was very well meaning. So that's the reason why Supermicro's IPMI is randomized and the little tag figured out. So a lot of products that previously would have a default password can only have a default password because of the state of California law. So what happens instead is the vendor has to come up with a password based on the serial number for the machine that's unique. In the case of the Brother printers, the folks at Rapid 7 reverse engineer the algorithm, and given the serial number, they can now compute the password, which is no big deal, except you can also go to a web page and get the serial number. So now you can just go to the web page, get the serial number, decode that, and then log into the machine with it. And the Nuclei project that's written in Go, they wrote a fantastic, it's actually JavaScript embedded into a YAML run by a Go engine. But what that does, it actually does the full crypto lookup and computation. It'll go grab the serial number from Brother printer and then decrypt it and then give you the real password to it, and then actually log with the password to verify that it worked. So you can do an amazing amount of stuff in a YAML JavaScript thing in Nuclei, but it's really cool. The funny thing about this is we'd actually been getting the serial number for Brother printers to work for like 5 years. We used a totally different protocol for it, something called USCAN or ECL protocol. And it was just kind of a neat hack we thought it'd be useful for telling people what they had, like their inventory. After this came out, we're like, well, crap, this is not technically a vulnerability that we're giving the serial number. So we had to start reporting it as a vulnerability, even though it actually makes our product worse because then we can't get the serial number anymore. So the good news is Brother can't fix this in their current hardware, so they have to change their manufacturing process to fix it. So you probably can still exploit this one. The other really fun thing with printers is people often set them up for LDAP authentication or SNMP or SMTP. And if you can go into the printer configuration and then change the destination IP address for one of those things, like instead of doing LDAP to the domain controller, you do LDAP back to yourself, and then you run the Flamingo, you'll just get the password hard-coded into it and sent to yourself. Same with the mail server. Like one of my favorite hacks is you change the mail server to your own computer, and you basically tell the printer to mail you something, and then it gives you the clear text password to configure with, and then that's typically an AD account. You can log in and take over the AD using that account. So lots of fun to do with printers. They're kind of a favorite punch bag. So going forward, how do you get all the good stuff? I don't want to spend too much time on this stuff, but one of the shortcuts for breaking into things, and I think I talked about it last time, is these little KVM devices. Typically like a KVM or out-of-band management device will have less security than the device it's hooked up to. So you can either spend all your energy trying to hack a really secure server, or spend 20 minutes hacking HPILO or the whatever connected to the thing out-of-band and then take over the console that way. So typically the weak points of a lot of servers tend to be out-of-band management services, like IPMI, for example. The protocol itself will leak the password and you can crack it. Lots of fun stuff. So IPMI, so if you get a brand new Supermicro, they will randomize the default password, but it doesn't matter if you get the machine to tell you the password crypted with SHA-1 or hash like SHA-1 and just crack it. So if you want to put aside your LLMs for an hour, you can crack passwords using the same GPUs, and then basically get the default password for any Supermicro by cracking it straight from the rack key protocol thread. This is a tool that I think I'm trying to report this over to Go yet. If not, I will soon. But there's a funny bug where some people will try to block NFS access by blocking the port mapper. The way NFS, the network file system works, is there's a thing on port 111. You say, give me the port number for mount D, give me the port number for NFS. And then once you have those port numbers, again, ask mount D, can I mount the thing? It says yes. And then you talk about the NFS service for 2049, which is a different port. So you're talking to 3 different services to make it all work. A lot of folks don't realize you can just skip one of the services. You can just ignore 111 entirely and just brute force the port. So program IDs, you find the other ports directly. So most of these NFS as well as port 2049, that one's easy. You have to go brute force the mount D port, but that's typically only 1,000 ports. You can send it to install it. So this little Perl script in the Go program, what it does is it basically sprays out NFS commands on the network and looks for replies. And you can often find NFS servers that are open even though RPC bind is blocked. So this is actually how I got my first job. I ran this across the internet and found all of Yahoo Mail's mail servers on the internet, exposing the entire mail spool for all Yahoo users. So it's like 1411, lookup.com, Rocket Mail, we're all using the same servers. And there's 36 NFS servers. Each one of them have a directory going from 00 to ZZ. And each time each of those directories is 00ZZ, 00ZZ, and you keep doing that chain about 5 or 6 levels up, and now is your user ID. So when you're getting your mailbox from Yahoo, you're just resolving your user ID and then looking up the NFS directory and pull the .mailbox file out, and that was it. So the demo for the Yahoo team was I mounted their mail server on my crappy little dial-up machine, and I found the guy's email address that I was talking to at Yahoo, and they basically mapped his mailbox to my web server running Apache. So you go to like my little web server on dial-up mode and refresh it and be his mailbox. It was great. So that guy, it was his first day on the job at Yahoo. He ended up being the co-founder of WhatsApp. So that was Yandy Kuhn. He was my first job reference, and he went off and sold it for like billions of dollars and gave all the money to Signal, and that's why Signal's awesome. So, it's a 25-year story really quickly. But anyways, there's more stuff here, but basically there's lots of fun tricks you can do with it. And Go is awesome for all this stuff. Any other examples that jump out here? Oh yeah, a really neat thing you can do with Go is there's an entire userland stack for WireGuard. So WireGuard, if you're not familiar with it, it's kind of the protocol behind Tailscale and other VPNs. It's secure. You can't easily scan it because it's kind of like you don't get a responsible server unless you know the key. But someone built an entire userland IP stack that sits in whatever program you want and makes a full IP connection and stuff like that. So you can actually have a web browser that just starts up a WASM script that then runs Go with the WireGuard stack inside of it. It makes a full VPN connection out from the web browser to whatever. You can SH it, things like that. So you can do a full VPN from any application, not just, you don't even have to have OS permissions. So if you're trying to steal data from a company, you can basically just use these little Go tools to build your own little mini WireGuard tunnel thing and break out. Another tool is called Stun Mesh Go, similar concept like WireGuard. It uses stun and turn servers to basically set up NAT hole punching. So basically just knocking holes in the firewall so you can talk out quickly. And these are really great ways to steal all the data from a company quickly where they can't see it because it's over encrypted DP and it's also really fast. Other fun tools here, I think these are all Go-based, are shared drop, work home, pure transfer, but very similar. So yeah, that's this talk. It's just there's a bunch of references here. I can send you to that afterwards, but most of this stuff is in Go. I've got some little demos here of the tools, but I don't want to take too much of your time. We saw the detail thing here a minute ago for watching tweets get registered in real time. Here's a little Flamingo tool. You can just run that here, and basically we'll just list on a ton of ports. And if you're on the Wi-Fi network and you scan the network, it'll basically show your password and stuff like here. So really handy. And the neat thing about it is it doesn't give ports and use them. It'll try to rebind over it. If it can't do that, it just says, hey, it can bind it, but otherwise it'll bind everything else you tell it to. NextNet, this one's not super helpful in this network, but this is how you look for NetBIOS. This is the DNS remote port scanning tool we've got before. So we're gonna ask 9999, the Quad 9 server, to also port scan the 111 server for Quad. So in this case, we told it to resolve 1100/29. And you look at the response codes here, you can see that 1111, 1112, 1113 all responded within 272 milliseconds. So we know those are actually real DNS servers with real responses, where we know that 11045667 does not have a real DNS server on it because the timing is different. So we can basically make one DNS server scan other DNS servers for us, including ones beyond the firewall. That's just a really quick hack for it. And I think that's it for this. I've got a second talk that I don't really want to get too much detail on, because you've probably heard it before. But the short version is, I work on this thing called Shamble. It's basically a really evil SH client. It's all written in Go. And we did kind of a huge thing last year at DEF CON where we found tons of vulnerabilities and talked about it and found all this stuff. And then since then, there's been a ton of really cool SH attacks. And we went through and basically said, okay, let's see what happened last year. Like 12 months later, what happened? Nothing. Everything's still the same. It's actually less SH internet than there was last year, and we're actually down to 2018 levels of SH now. This is because a lot of the tar pits and fake honeypots actually got taken down. So most SH servers on the internet are actually real SH servers now, not that. Barely anybody applies patches. That Shamble, we did an IPv4 scan all the internet, compared to Shodan. Numbers are really close, so I was going to get kind of a second eye on the B-stats. We said, yeah, it's actually it. But it's actually no real changes. The only thing that was different this time is that instead of scanning just port 22, we scanned the top 110 SH ports from Shodan. So we did that, 4 billion IP scan 110 times. And then every time we found an SH server, we ran the Shamble tool against it, and it basically automatically tried to break in and take all the stuff. And we got about 130,000 sessions this time, which is a little more than last time. And about 10K are honeypots, 17K are sonic walls, and about 50,000 are like real shells though, like just straight up off bypass dump into a shell, just by doing some dumb protocol tricks. Here's what it looks like when you're scrolling shells up the internet. So just thousands and thousands of root shells just flying by. The hardest part of this work is trying to figure out what these things are. So it just takes more time to go through all the loop than does actually find it. But yeah, fun tool, all written in Go, of course. And we've got 3 new bugs. First one is really funny. It's a carrier switch used in Thailand. It'll give you an unauthenticated shell on port 1022, just by using the SH auth method of a null bind. So instead of an auth method of null or an auth method of password, whatever, you literally give it a null byte for auth method, and it just drops to your shell, or it bypasses the net authentication. Another fun one here is, I love this one because when you first SH into it, you'll see escape character is block. Like, when you was familiar with that string, that means it's actually running telnet. So you're SHing into your computer, it's automatically logging you in, then it's doing telnet back to itself on telnet port, and then it's giving you a login prompt. And the funny thing is, if you type in the wrong password 3 times, it drops you back to the shell. So you literally just fail to log in 3 times and you get a free shell. It's a super dumb bug. This other one's really funny. It's a cloud Chinese ISP where they only support you if you're on their management agent. Just like DigitalOcean has like a little agent, droplet agent running, same thing, or Azure's got one as well. You have to run their little agent, and they contractually require you to install this agent if you want support from them on the cloud side. And I think it's even called like Cloud Bastion, something like that. It's pretty generic. You can probably find it. It's semi-anonymized here. You can find it really quickly. So this thing runs in 5.0.0.2.2. It's written in Paramiko and Python. Because Python sucks in general. You can actually do an auth bypass, and it basically, you use any public key for a user that doesn't exist, and it drops into the shell with user none, uppercase N, or the Python nil result, basically. So really fun, stupid bug, but another fun way to get stuff out of it. And I think that is it. So, example of the bonus bugs of getting all the free passwords while doing this, and then the shamble stuff you can find on the internet. It runs through Ink and GitHub, and it now integrates the bad keys info project that I talked about here, meetings back. And the next thing we're doing is porting all the shamble code over to the nuclei code, so you can just run the nuclei scanner and they get all that safe checks for free. It's perfect. So that is it. That's the talk. Did I miss anybody coming in who's not on the list for the raffle yet that wants to be on the raffle? You out there? What name do you want?
Brandon.
Brandon? All right. And then next up we've got Drew. Hey, Drew. What is the airplane?
The airplane works well. That was great.
Okay, yeah, I should be able to do a lot of good stuff with it. Should be Antone stuff. Dedicated saw, I'll drop a link into the Gopher Slack ATX with all the references and links.
What are the implications of front running?
Anytime someone has a web application that defaults to setup mode, you can basically set it up for the real user does.
Yeah.
Then back to the machine, then reset it.
I mean, legal.
Oh, it's all legal, right? I mean, you're felonies all day long.
Hmm?
It's felonies all day long.
That's the CFAA one right there.
Yeah. I mean, I don't know, you're not really.
No, showdown's probably not. That's more like a weird gray area. But like, front running would definitely be like illegal. Yeah.
If you're logging in,
For sure.
I don't know, it does say please log in.
Yeah.
No, so,
That would be your defense, Tim.
What's a safe way
your password words.
doing that? There's gotta be a safe way. Like VPN.
Like, when you don't have stuff that has auto setup on publicly accessible stuff.
What would you classify as a safe way of doing that?
Have a lawyer.
Like technology.
You can detect it about exploiting it. So you can just like check the website and say, is this a set page? And if it's a yes set page, then we'll report it. Or just take a screenshot of it. It's just, you only really break the law once you actually do log in and do the stuff. So just detecting it typically isn't considered a violation of CFA.
So you never do stuff?
You never admit to it now. When you're doing a pen test for a customer, then of course you got permission to do all that stuff, right? If the company has a bug bounty program, that's in place also legal. So one of the great things about 2025 is you can go on the internet with bug bounties and like go hack big branding companies and not worry about going to jail. Just stay up the lines of bug bounties. So and then they pay you money if you find stuff. It's pretty cool.
Yeah.
You're competing against like a million other people, so it's definitely fun though if you want to like get into it and don't have a full-time pen test job. You do bounties instead.
So what if you try like the free private passwords, that thing, and you drop into a shell?
I don't know. Well, technically you're hitting enter, so you're trying to log in. So I guess safe payroll comes out prosecutorial discretion, which means if you piss off an attorney, they'll go after you. Otherwise, no one cares. That's pretty much it. Sorry, Drew.
Yeah, that's that. Let's see. Just before I start, if you just raise a hand, just raise a hand if you're familiar with like CRDT, what that means, if that's cool, right? Or this, if you're somewhere. How about an LSM database? Cool. How about IRC? Woo! Okay. Great. My name's Drew. How's it going, y'all? Nice to be here. Fellow Gophers. I don't know about y'all, but I would have left software probably some time ago, or died somewhere in the C++ tar pits if there wasn't relief. And I don't know about you, times I've gone back, right? You know, and you just get those like PTSD moments of like, did I initialize this variable? And like losing half the day because you forgot. Like, no, Drew, you're fine. Anyway, my background has been is in graphics and high performance databases. And about 5 years ago, a good friend of mine, we sort of embarked on this project that we'll display in the background as I talk here. Right, so what you're seeing is a time lapse. You're seeing the Unity 3 engine run, and the idea was that there might be these things called 3D games out there. However, it's been more interesting. What if you use a 3D engine having embedded Go library that empowers all your data and things, offering things like network access, arbitrary data storage, and whatnot, talking about security. So what you're seeing here is just sort of the generation 2 of this project. And as it's all the things that are happening here, as you're posting things, it's sending those changes to the Go, the generation 2 Go node at the time, and making those changes and just sort of basic So the third generation stuff I'm showing out today, it's great that we're talking about security from the first part, is getting the back end into the CRDT, for those who are not familiar, that's conflict-free resolution. Look at the acronym, but basically all the different conflict-free resolution data. So you can replicate, send all the pieces around, shut up as you want, there's no way that you're going to be in the same state no matter what happens. Now, there's a lot of details in there, choices. There's some downsides that we can think about, find, and we can come back to stuff. But so far, I went through a million things so far, but any questions or something that jumps out so far the big picture. So the big picture is, yeah.
You said your backend was Go and CRGT, but like, is your front end like Unity or something? Or what's the
Yes, thank you. Yeah, so to bring clarity there, the purpose is to, let me bring up a little heavy game diagram here. So the sort of overall, what you're seeing here is you've got your main like client process here, and then the idea is to this project runs either as an embedded library or headless here, where you've got, sort of a common pattern, or at least the one that's used here, is you've got sort of this host that you start, and then you attach different modules that you want to hang off it, such as library service or a different kinds of network service. And the way that sort of we offer the modules is app module stuff that gets instantiated into an app instance by the host once the right request comes in, and so now your session has access to whatever instances that the host, that you have invoked through the host. Okay, and so, and last but not least, yes, so the goal being is that be able to offer a high fidelity a user interface and all the kind of richness like you saw there in some of the video, but while not, by having kind of a rich set of data options, so that, as we, we have, from the first part, we can all hear, whether it's Firebase or some of these different big role-based databases stuff that are usually a train wreck when, for casual developers, because it's usually people don't spend the time to do the roles and stuff, and rightly so for people that aren't developers. They don't even know about that stuff, right? So hence all the crazy stories out there. So the core principle here that's not obvious from the diagram is, so I mentioned the IRC model, which is pretty wild, but then also, so think of it now, instead of, we think of IRC as live. So now imagine that, we already can imagine multiple channels multiplex through one connection. So now shift that, instead of the multiplexing through a connection, multiplex through, say, a CRUT or something where all the channels and all the entries in each channel now shows up as an entry in this database, and that the database is replicated around. And then further, if each channel has an associated access control list or something that controls permissions, you can now imagine something where you can have an entire persistent and cryptographically wrapped corpus of all your channels, so that the administrators, to invite someone in the planet or the community, call it, they would basically insert a new member entry into one of these channels, and you can there's lots to go into, but it's basically this persistent based cryptographically wrapped IRC implementation, where all the content then propagates through this database that, because it's all wrapped, you don't even have to have it, transport it with anything encrypted, because the entire, each entry, the only thing in the clear is, a UID of what community this is, and what epoch we use the term epoch to describe which set of crypto the current administration is using, right? Because if let's say we're all in one of this community here, right? And let's say y'all are the admins, and I come in, right? If I request to enter the community, you need to issue me a member ID and make my first Genesis password that I would then step in and replace, so that I put my own asymmetric public key and stuff, so that other people can send me traffic, but if, let's say that happens, time passes, and then now you guys want to kick me out, whatever, it's time to remove me. Well, I still have the public key for the current epoch of the community, so I still have access to see the entire community's traffic.
Yes.
So to remove someone means that, or to have any change like that, you have to advance the community epic, which means a new community key is issued so that everyone can now symmetrically get the data inside of this corpus, and then private channels inside of that can go on and stuff. So it's interesting to see things move in time when it comes to encryption, but it's the same, so that there's a lot there. So what so far, if there's any questions on that so far, or I know there's lots of pieces, but that's the idea is again, IRC inspired channel system, multiplex persistently, wrapped cryptographically, with the benefits of being able to plug this into a 3D front end and have rich fidelity graphics and stuff like that.
So then the idea would be that you would, because you're building this system, and then the idea is that like your customers or whatever, or people who are using this, want to build, applications like you were showing, like a 3D representation of like the music festival they're at, or something about disaster recovery. Instead of just having like a flat 2D map, it may be a lot more useful to have a more interactive like 3D world or whatever. You're making the tools that someone else would then be able to easy mode go put that together at the last minute.
Great way to wrap that up. Now even further, even to provide an SDK so that it's even faster. And that was sort of the idea, is that so that way, whether you're a junior or senior developer and 3D type person, you can be dropping in this data stuff, and you're not even, it's impossible for you to mess up security because it's all under you.
Yeah.
Which is pretty cool. That was sort of a big gain from it.
And so kind of the secret sauce here, I mean not secret, it's, you're upfront with it, but like the idea, the main selling point here is because you're making very good use of known technologies, but using them in very interesting ways. You're using these things together to make it so that they can do things that we normally would think are not practical, like how you have all of the different people at a music festival talk to one server without knocking the server down or like hosing the connections from the network. Well, if you're dealing with CRDPs and that's how you're communicating the data, well, there's a lot of that logic can happen inside of the app rather than out at the edge of some server, and the people in that network can still trust each other, that they're not getting man in the middle or whatever, because of just the nature of the problem. Like
well said. Yeah, so a couple of things. One is, so the nice thing about this is the CRDT stuff works well for local first. And to your point, so that way, whether you're at a camping trip or Burning Man or whatever it is, that you can be, you don't need an wide area network for this stuff to work. And stuff like man in the middle is even NA because all the traffic gets encrypted, before it even hits. Because the stuff is embedded in the app, whenever you're in the app and you make a mutation, that's going to go into the system and then get encrypted with your key right there in the client app, and then it gets pushed out to the community to replicate, or wherever that is in. Just replicates from there, are encrypted.
So then I guess the idea would be like, let's say that ACL Music Festival decides to implement a version of this so that you can see where the different concerts and stuff are going to be, and who's going to be on what stage, what time, things like that. And so the idea would be that they would then publish in the app stores like Android and iPhone or whatever. Here's the ACL2 Music Festival app, but then on site, instead of having, maybe they do it over the internet, or maybe they put on site in a data closet somewhere there in Filter, they have a rack of computers that are doing all the server and stuff. And all the people's phones will still trust it even though it's over the local network, because you've got all of the things taken care of when it comes to the data structures, all the communication protocols and everything kind of handled for them. And it's not gonna be this huge effort for the people at ACL to go and build this stuff from scratch because you're building a platform.
Yeah, you got it. Thank you. Well said. Yeah. here's a diagram of a lot of those things brought together that hopefully helps a little bit here, right? The idea is, look, we've got the top part in red, right? We've got these powerful 3D engines that we're obviously all familiar with in certain ways, but you know, yeah, we're in 2025 and almost every app you're sharing data in is a bunch of rectangles, you know, like something's wrong, right? So that was another reason why we're sort of into this. And you know, meanwhile, you've got this community-centric kind of permissions and data model, like whether it's I or C or things that, you know, when someone loses their account, you want to go through the community or the, you know, the local organization. You don't have to go to Redmond or Cupertino or that BS, right? So, which we know is more important than ever. And then, you know, on the bottom right there in blue, we see the notion of, you know, persistent crypto, right? Which everyone takes to think at first money, but it's way more interesting and practical that all those same concepts apply to, you know, keeping your community in a container. And I say community, but and to your point about, we said like ACL example is a good example, but also it's for your home media server kind of stuff, right? It's anywhere where, so, and now let's get back to where it starts to get interesting and nerdy here. So, well, so just to finish up this. So, and this, I know where I was going to go. And this latest, so that what you're seeing here is called the Art Media Platform, or AMP for short. That's what it's called now. The previous generation, the plan stuff, it's still there, and but the Art Media Platform really was the addition of a lot of media and real-time AV features, which that sort of now that kind of is a lot more relevant to being able to access for your people's private data servers and stuff. So once you think about people who you might share files with, whether it be like significant other and the kind of stuff you would share with them, and you start to think about all, you know, and it's already a known fact apparently in Hollywood and all that all the people, celebrities and stuff that got their phones, you know, there's, y'all probably know, there's, we just saw the first half hour of boatloads of exploits and that stuff. So apparently it's an entire thing that early, like before you go back, celebrity phones have been like hacked big time, and they use that stuff for blackmail and for, you know, just for money and stuff. So, you know, in an era where you're pressing an I agree button to have your data scanned by companies, you know, this is also the basis for why we were sort of set off on this project, because it was just sort of harrowing to think like, why is it 2025 and we're, you know, we just see how many times are we doing round trips with data when your data is like, you know, just down the hall or whatever, going to big servers and all, you know, and broadcasting everything. So that's sort of that's sort of the big picture there. And so the CRDT has been a journey, and the first place to start is in the Generation 2 stuff. You know, there's sort of the channel ID, or you know, we have the channel ID that's within a given planet or community. That's, you know, where all the that's the entire container. You can have multiple. So think of a planet as a database, all right? And so the address is broken up into 4 pieces. Now, historically, in the second generation stuff, historically in the second generation stuff, you know, what you see in a lot of database patterns, you have some kind of switch or identifier, a path or something that basically says, okay, you know, you've got this UID, this first part, and then some sort of basically path or fragment or something that's a switch for a command. It's which typically often we see a variable length string, right? Something, but there's a big problem with that, and you know, as y'all can imagine, once you start having to traverse, you know, a large database stuff, you have to do a lot of sticking and moving for variable length keys. It turns out, as most of us probably here know, that having a fixed key size offers tremendous advantages when you're talking about database performance and things like that. So after a lot of iteration, what really worked out well was, so here we are, so first let's mention that we're UID here, we're call it conventional here, which is gonna be 16 bytes here. All right, so, and we say just by convention, we'll say, look, it's, you can use it as, you'd expect it to be completely random, or alternatively, you can use it as a UTC timestamp with like 10 bytes of fixed precision. So that's like, to give you an idea, that's like 4 million years for a 16 bytes, right?
Correct.
To work that out. So,
Yeah.
so we're pretty good for that. And so why that kind of course, there's the precision that's pointless, but can anyone think of why that choice was made, or what's interesting about having a timestamp with an unusually large amount of fixed precision? Well, if it comes to you, we'll get back to it.
Less complex?
Close, yeah, right? So it's pretty much like, think of why do we like UIDs? Why do we like, what's the purpose of a UID, right? It's essentially collision proof.
Like
So,
if you have a UID v1 and have IO fixed precision, then you can just do based on your local clock, you'll get something that's different every time.
yeah, well, so if I heard you right, you're saying you could use a local clock, but even depending on the system, often the local clock will only give you, different amounts of precision, but you can inject artificial entropy, and you're basically right up there with a UID. Now let's just put that aside for a second. So what I mentioned, we, typically when we're sort of storing arbitrary data, it's, we have this sort of variable length thing. It's typically like, in these examples here, they sort of, we recognize that the keys imply the type of data, right? We know that there's different approaches for how you want to type data and things like that. But when we can say that if the key can be arbitrarily specific, and we have the address space, or we have the size of 16 bytes, we have the ability to, so the short version is basically these things are called tag names, and we form a hash, but it's not just like a literal hash. And big fan of Blake 2S, by the way, shout out for Blake 2S. And so just to get a taste here, notice, so on the right hand side is sort of is a golden file. If you're not familiar, a golden file, great way. I think we talked about it last time even. It's a great way for, if you've got some input-output thing, you've got a fixed input and you want to have your testing, always check that the output from the input should always match a golden file. It's a common way. I'd highly recommend. It's great to debug and all that. So, and then when you run your test scripts and stuff, if any of it's different, or you see even if you're you just see the file's modified and different, something's messed up. So here we're looking at a golden file for a bunch of tags here. You can see in each of these, the first line is what the input is. The second line is the canonical version of the string, and then the left-hand side is what the 16 bytes and base 32 is. Now, the reason I'm showing you this, because why the heck would we want to look at something that's hashed, is there's a feature that was sort of fun to make here, which was we wanted the order of the literals within these strings to be commutative. That way, so for a couple reasons. One is it's great for like easy searching and like AI matching, right? If you imagine things that you're looking for, the fact that they're unordered is a lot more sensical for searching and ranking than a fixed order. At least if you're talking about things like keywords or attribute fragments that you want to be there. Because remember, an attribute or any given literal can be as many bytes as you want, and now that just gets baked into it. So that's what we see here. So you can see the order changes around and the hash stays the same, right? And If you can't read it, well, of course you can't read it, but basically what you're looking at, oh, here we go, yeah, let's just see if we can do that here. Right, so you can see the order shifted around in there, and some of these, let me find one that's a little. But the takeaway there is that, so arbitrary attribute sizes are now packed into this 16-byte thing, and now that offers neat features with being able to match it. And one of the other nice things is you can operate this in secure mode, where all the tags are gone and just the hashes remain. So even if someone gets your indexes, all they have are the hashes, because we know that a channel name or a link or something that's got information about your surprise birthday party, obviously, like or insert your thing there. So back to this here. So the goal is to be able to make entries that are to never collide, and then also importantly provide a way for like large bulk data. We're talking like 100K, 200K, million data members, right? So anyone familiar with database stuff, if you just start playing the game where you're going to put a million data elements and have a same data path with a million data elements as like the scalar items in your app, you're not going to make it, right? You really have to have a strategy for how bulk data is going to be processed in a way that is not going to take things off. Well, I should say take them off the rails, but just make things good. So what the idea here is we have the channel, we have the schema, which can be anything, and then because of that, whatever that is, you can directly apply what your item, what your payload's going to be. Maybe it's an inline, maybe it's, remember, you got 16 bytes, so that's a lot. I mean, just as a point of reference, a 64-bit S2 tile is about like 2 square centimeters on the face of Earth. And you got 2 of those, right? So for S2 tiles, an encoding of that long, and so if you use the full 64 bits, I'm just giving you a frame of reference. It's easy for us little humans to forget about how big 64 bits is, right? So when you have, 128, you have a lot of options for even the inline case. So, and then you can also put anything you want in there. You could put other, okay, so what about data, right? Okay, inline, great, but what about data? So remember, this is a key value that will be used to retrieve a value. All right, so if you're not as familiar with this stuff, think of it like your key value database, but in an LSM database, a log structured merge tree, fancy name, that just means like a very high performing, low level database where you're deciding essentially, if you think about 1,000, you pull out all the words from a dictionary, right, and you alphabetize them all in one list with just that, and you were to sort of scroll by that. That's essentially, an LSM value by value or key by key, where you're lexicographically, each item is sorted. All right, so let's say now, so the idea was as well, in a system that's supposed to be flexible and something where you want to accommodate anything, whether it's ACL or whether it's, or all these common entries from all of the boilerplate channels like messages, placing things in space. Those are going to have values. That might be a couple values, that might be 10 values, 20 values, right? But keep in mind that because you could put, so an array here by having as many elements as you want in that item slot, that's your array. So if you were to have, 100,000 elements, that you would have the same attribute for them, and then you would have however you want to differentiate them as the item ID, and then the value can be whatever you want. Now, the tooling for this is set for protobus. You can use anything, But the advantage of something like, so you can use any value structure you like. But the nice thing about things like protobufs is, well, you can use anything, I'll just leave it there. As you might be familiar with, there's a lot of ways to serialize stuff. We've left that open, but we sort of happen to use protobufs there. But importantly there, the other sort of challenge with CRDT stuff is when you start to have a lot of edits, or if things are stepping on each other, you ideally want your value to be as lean and small and narrow as possible. Because the wider or more intricate or more capable or larger your your data is, the higher the chance that like the app you want to make or you're designing, that if you want to rewrite that entry, you have to rewrite the entire entry. So the strategy here to make this work was you get your parallelization of data with this item ID element, and and then your values would be typically on the order of a few K or less or whatever you want. But the idea is you're not putting. The idea is to take advantage of the parallel or the array aspect of it. And last but not least was, so if you're rewriting the same item over, well, okay, obviously this last part has to be the differentiator. So the edit ID is essentially a composite of the most recent, or like the revision you're replacing and the current timestamp of the transaction that is sealing your change. And as we talked about at the top, that's basically going to give you your unique UID that is, not going to be guessable. So, and then on top of that, when you start to name an entire, if you're in terms of security, it's not just 16 bytes. You're in control of the item ID, the edit ID, or we'll call it, say, half the edit ID, since it's, depends on how you want to measure it. And you're in charge of the attribute to, depends on if you're using a one for the system or your own. Right, so there's a lot of choices so it's not like security's at 16 bytes, it's the entire width of this, or it's arbitrarily large based on how you want to seal the transaction. Hopefully that makes some sense. Let's take a look. You can just see, well, I'll just leave it there for a second. Any questions that come up so far?
The only take offhand is you might want to use the second UID for random instead of using timestamp, just trying to randomize it. There's a problem you run into when someone does a race attack. So effectively, if someone connects to your server and they smash in like 1,000 UID requests all together, and then they manage to overlap one of your requests being processed, they can see both sides of yours and then zero in the difference of it.
Yeah, that's definitely a good point. So the response to that is a couple of things. The midpoint thing causes it to, so the midpoint, if it's not clear on the CRDT stuff, when a channel is loaded, the traversal goes in the database from high to low, because the idea is you're going backwards and you want to pick out, you scan backwards and you pick out the highest edit ID, which is basically a naive implementation for getting the newest entry. And then once you get that, because this is an LSM database, you can just, very low cost, skip to the previous entry with a new, different item ID. So you effectively, that's how you read out all the item IDs with a high performance way. Now, so the question is as well, there's downsides with this UID timestamping stuff. And so I do have that flexibility to have it in there. Another nice reason for the, let's see. So yeah, we do have that. What was the other thing? I'll come back to you in a second. So.
How do you truncate it? Like, this is going to be a giant LSM, so how do you drop the out of it?
Oh yeah, so yeah, just so on to finish out the UID thing. So it's you've got the size of that thing is so large. It's not like it's just limited to the computer's clock. It's got purposefully all those extra, just as a point of reference, right? There's Well, I would love to do analysis with you, cause that's, but I'll see if it holds up to what I think it
Cause
does.
like a GC stall to happen, we'll have a bunch of requests for queue, they're all gonna have very similar.
Oh, sure, yeah, but keep in mind that a mutation is only entered in when you make the mutation. Now, once it's like as if you were signing a crypto transaction, right? Once you sign that transaction, you're doing that like in that moment, in that time, and after that, it's that sealed transaction is immutable. So the transaction, basically that gets generated, the ID is essentially not subject to do that. And now we go back to that's why all those transactions can replicate around, because they're already sealed, as in they're signed, and they're also encrypted, requiring the community key, or in the latest there. And then what was your second? It was
Just like if you can, like an attacker can cause your process to stall, and they're able to like push a bunch of IDs at once, and theoretically, if they can leak their own ID back out, they get like the range of values that your ID would have been. It doesn't really matter, I mean, if you have, I guess like how important is the non-guessability of ID is really the question.
it's not really that important, because you've got, it was just sort of icing on the cake, and sort of to provide sufficient assurance that you're not gonna get a collision before you play the lottery kind of thing. But that's a great point. Great. And so that's been the journey, and so just it's been coming together. It's been pretty exciting to see come alive. It's like all of our hobby projects. You don't know until you're like neck deep and way behind, right? I feel like that's how it goes, right? Well, the AI is like, I don't make AI jokes, right? Anyone else feeling mildly insecure about?
Oh, how do you drop data? How do you drop data from LSM?
Oh yeah, thanks. So just by doing any kind of copy or replicate, you can just make choices about, like, so an archival thing, you would just have an archival export, could just, it's probably intuitive, right? You would just exclude everything but the latest edits, right? If you want the latest, or you can, if you're doing archive, you can just opt to export those as well.
Live DB, are you clearing old entries, or like, I guess you just keep it running for a couple hours, you start stacking up to do it?
Oh, that's a good point. I mean, I haven't put any stuff in yet for removing stuff on live, but I don't really see that as, anything major ahead, since you're just dropping entries. But yeah, that's certainly a thing. See anything else here?
What LSM are you using for it?
Badger.
Oh, okay, cool.
Yeah, Badger. I've heard great things about Pebble.
Pebble's awesome.
Yeah, I was sort of, once I heard about Pebble, I'm like, but I looked at, like, they're so like similar, it doesn't really matter actually. But yeah, I think that was the idea. But yeah, it's been super fun. If any of this has been interesting, again, my name's Drew. There's lots of areas and fun stuff to do on this, and like I said, the motivation is really honestly around the off-grid stuff. So like, whether you're camping or your own your homestead stuff, being able to have a secure enclave that you can hang your hat on, that doesn't rely on, like, whoever just, doing their job, right? And after seeing the first half, I just get reminded of just like, that's, just 80 miles an hour of exploits and stuff is a trip. So to me personally, I think it's exciting to be able to secure data and have it, my own stuff, and with the 3D front end, and importantly with the AV media integration. So if you put that together, you might be able to see that where this goes is basically an AV player that's multi-platform, because the thing you get out of a 3D engine is you get all the platforms: iOS, Android, Windows, Mac, Linux, right? And so that's why the embedded library with the headless thing is a great setup. So that's what I've got, y'all. I appreciate you listening. Again, any interest in that stuff, all the way from the network side to the database side, or learning about that stuff is super interesting. And there's lots of fun spots to do, and I'd love to work with other people that are interested in that kind of stuff. Especially if you like music and audio and video, being able to be in a world where you can access that stuff on your own and not be totally sold out by all the crap software out there, and then all the stuff that's selling you, which to me is pretty enticing. I don't know about y'all when it comes to audio and video, and then being able to share that stuff with different networks or different as in people. Because keep in mind, the same with that kind of database form, you can have all stuff be interleaved, so you could have multiple communities or planets interleaved together, and they're all with like a secure air gap, right? So it's like the equivalent of that. Like in military networks, they say air gap is this sort of term to be like used to like, well, the only way we can secure this is by having physically separate air gap networks, which is sort of laughable after like the 5th or 6th network, and you just wonder how much money is being spent, and you want to like jump out of the window. But in the modern era, being able to interleave that stuff together, but also still offer the same security assurances, so that that any compromises are always going to be compartmentalized is super interesting. So thanks, y'all.
Good questions.
Go.
What are the advantages of using LSMs?
You're in charge of the database. I mean, whether it's Pebble and great question, by the way. And it's whether it's some of these, all the different LSM databases, what they all have in common. It's basically like a key value database, but it's almost in a way even lower level in the sense of your key is just you give it this bytes. Things like Go, of course, you can like really make it crank, so there's like no allocations happening, and it's going. It's and things like Badger and Pebble can be doing a lot of stuff in parallel. So that way, if you've got a whole bunch of, the way they roughly work typically is you start a transaction, and then you would read and write entries, and then you close a transaction, and it will tell you at the end if you need to redo it if there was a conflict. Most of the time there isn't. Rather than like it trying to figure out things or it trying to have a structure. So the other thing is that there's no structure in these things. So it's the key and value. So usually you're going to want to have a system where either all the values are very similar, the same, or like in this case where you have some kind of switch that lets you know exactly what value is there. But their advantage is that you can traverse them very quickly, very low overhead. Yeah, unbeatable performance, honestly. They're just insane. With that and Go, it's crazy. If that helps, hopefully, I don't know, feel free to ask more, but yeah, they're fun to get into because you can crank the performance and you don't have to worry about fighting the database API.
Gotcha.
Cool. Well, thanks again, y'all.
We've got lots of pizza back there. I don't plan to take any of it home, so whoever wants to take whatever is left there at the end, go for it. Whatever beers are left, I think we'll have next month. I'll be out, but if you'll be here, so. Like we said, in October, we want to try to make it so that it's not just HD and I. So I appreciate getting more talks like yours. Thank you, and would love to have even more. Please jump in. There was an interesting challenge that was thrown yesterday by the WebAssembly group. That there's a bug, an existing bug out there right now in the Go compiler that you can't compile Go to 32-bit WebAssembly for some interesting reasons. And so if anybody in here is bored and wants to dig into a weird and tricky, nasty problem, there is an upstream bug open. I think we posted it in the Slack yesterday. If anyone's curious and needs, wants to take a shot or or wants to discuss it with some folks, we've got definitely some people who are knocking their head against it right now, so it would be a cool thing to collaborate on. If anybody else is interested, just reach out in that channel. It would be cool to get some collaboration and knock out a bug that some people are running into. And likewise, if anybody else is running into issues, that is another thing that we have done in the past. We've had, it's been a while, but we've had meetings where the idea was rather than people presenting brand new material and cool projects that they're working on, just come up and present some bug you're stuck on and that you've been trying to figure out yourself and you kind of can't get past it or whatever. This is a great group to collaborate to try to figure out how to get past it. And so we've had meeting nights where it was just like one after another, just people coming up and bringing, here's the bug I'm stuck on. We all collaborate on it. Okay, cool, next. Here's the bug I'm working on, and same thing. And it makes for a pretty interesting evening. So definitely I would recommend if that's something that's you're stuck on something, by all means, come on up and we can do that at some point soon. Do we have questions or comments or anything like that? Well, is it raffle time?
Yeah, raffle time, and again,
Alright.
we'd love to get else's feedback on is, what do you want to do next month? Do you want to do like a hackathon where we actually spend a lot of time on it, prepare a pre-meeting, or do you want to just go like a turbo mode, pair up at the time and do stuff? And of course, what topic? So before we get to that, go ahead and do the raffle. So first off, he wants to code review my random function. This is how we do the raffle. So the lame version is int n with math v2, 14 plus 2, because the spreadsheet starts off at 2, goes to 16. So hopefully that looks right. Doing a range of 14 plus 2 and rand int n. If not, then you might not win. So does everyone agree that this code is functional? And then it just keeps track of whether there's already a winner, does try again. So it's not as random as it could be, but it's 30 seconds.
Sounds good.
Alright, so we're ready to run? Alright, our winners are, winner number 1 is number 3 in the spreadsheet, which is William. So William, you get a copy of Black Hat Go. Thank you. Winner number 2 is Index 6. So that is Brandon. Brandon, you win the Black Hat Spear kit with a DEFCON pirate flag and all that stuff. There you go. And our final winner is number 10. Number 10 correlates to Paul. So Paul, you win all this stuff. You got black nail polish, you got Lego things, you got sticker packs, all kinds of really fun hacker stuff.
You had me at Lego.
There you go.
It's good. Try to bring a little bit of DEFCON back for everybody, so hopefully it's fun. Alrighty, so for next month, so I guess starting off with, would anyone here participate at all in a hackathon, either flavor next month?
What dates?
You offhand, next month, is it?
Sure.
It's same time and place, so it would be the 10th.
Okay, yeah, September
10th.
It seems fun. Is that enough time? I mean, I'm
An hour and a half, whatever.
Okay, you want to start there and just, you got half an hour to write code, and then do show and tell, or?
Or maybe, yeah, I know, that sounds fun. How do we develop the crew or something?
Yeah, I mean, as always, the Slack is usually the best spot for this particular group, so I would say coordinating on the Slack ahead of time.
Okay,
was
good.
really-
Sounds like folks want to work on it pre-meeting.
Maybe something we can think about and noodle on, and then or
I
maybe
mean, you want-
something that gets spread out.
What IRC makes that.
Me too.
Yeah, like, I don't know, maybe it gets split like that way, it's like incremental pieces of, goes, it's like, in the middle of the night, you're like, oh my gosh.
So like maybe meeting 1, whoever's got something, maybe meeting 2, like October, do a second round of it.
A two-parter or something, or chop it up in a piece
I could
or
work
something.
I don't even know if I'll be able to make it next month, but I think do both.
Yeah.
If you want to do it ahead of time, do that.
Yeah.
Have like the speed round and the sprint and the duration.
Do you want speed round folks to have like a separate like voting and all kind of stuff? Like whatever you can knock out in an hour, or do you want
I
to
think
separate
yeah, I think
votes?
it's different classes. Yeah.
Okay.
It's kind of unfair to have people spending a lot of time on it when it's spent a lot of time on it.
Yeah.
So,
Speed round, which will be, start coding at the meeting, and then a, longer version.
We might have to double check if we did an IRC bridge, we might have to check with the Slack, the Go First folks if they're cool with that, but I suspect they would be.
Yeah, probably okay lots. Is there, I guess there's an IRC I'm not on, is it on like liver chat or something?
That's, we don't have one yet, but
Okay.
there was a request for it, so it's like, we know some people that know IRC, so.
This bridge is
yeah,
also
if you
small.
start on Freenode,
Yeah.
everybody just left.
Well, yeah, no, probably not Freenode, like.
No, I mean,
prob-
this was before Libre did it.
Got it.
Yeah.
Before Libre.
Yeah, we'd probably do Libre.
Oh, yeah, no, I know. Like I'm saying, there is precedent for IRC.
Yeah.
Alright, so while the speed round at the meeting, just for anybody who wants to quickly knock something out, and do show and tell there, and then the longer version will split up the demos across month 1 and month 2, because the folks may want longer. How do you want to pick a topic for it? You want to pick a random word out of a hat?
I think just do it and go.
Whatever is go?
Yeah.
Just
The,
go.
the first one, let's just leave open, and then
Okay.
the subsequent one we can take.
Okay, cool. I'll update the meeting invites for the next week to say, hey, this one we're gonna do a speed hackathon, but you can also do round 1 of show and tell, the bigger hackathon, and anything we know works.
Yeah, and I always like things that are like not the norm, like stuff people usually don't use Go for, or fun weird
Yeah.
stuff, so.
If anything,
that's what I
that's
was
a
looking
good
for.
thing, yeah. I
Like
think.
unusual uses of go.
Yeah, I think unorthodox
Stupid Go
uses of
tricks.
Go. Yeah.
Or like the other way, like maybe a performance, something maybe performance related or something.
Yeah.
That might be another variant. Something like, who can compute so many digits of pi? I don't know.
Compile a modern, see if you can get modern Go code to compile to old shockwave, runtime.
Well, it hasn't keep you anything, I believe it.
That's right. That's right.
Is anyone here not on the Slack? Alright, definitely join the Slack. So it's the normal go for Slack, and then the pound ATX channel.
Yeah, and we can,
And then we'll do all the coordination on there for like polls and asking questions and getting them kind of nailed down.
Wait, can we join it over IRC?
Yes, you can install Slack. I mean, if you wanna make your own bridge, sure, but because we don't control the go for Slack, so we'll either have to ask an admin to it, or you have to run your own bot. So you can join Slack, create your own IRC bot, and go talk to yourself in IRC if you want to, we don't care.
So what's the name of the Slack? It's Go for what?
It's
so,
diverse.
yeah, so you'll have to,
Roundabout way to join.
yeah.
There's like a weird invite system.
Yeah, I remember trying this the first time. I think I got lost.
Well, there's a Slack SDK for Go that I would mean to get into, but
Yeah.
You're gonna join without actually logging in.
There's a link.
That's it,
on a
golangbridge.org, that's it.
Okay.
So golangbridge.org, and then, there's a way there.
There's also a GitHub of like awesome communities or something.
Awesome Go?
No, communities, like,
Oh.
it has links to a lot of Slack or Discord communities. If you're not just looking
Yeah,
for Go.
GOLANGBRIDGE, right, is that right?
Okay, there it goes. Yeah, it just bounces to a Go Bridge
Yeah.
thing.
So there should be, there used to be like an invite button or something.
Is this the one with 111,000 members?
Probably.
Right.
It's
Sounds
like
about right. Oh, I thought it
it's
was
an
like a.
insane number of members.
I thought it was like a small localized. Slack.
So, so what they do is they have this like global thing, and they have like a special relationship with Meetup.com and a special relationship with Slack, and a couple things like that. And so then most of the local Go communities have a channel inside of that Slack, and so that's kind of the way it's kind of merged, is that whenever you go to whatever city or whatever, it'll probably be the name of that Slack channel.
Is it not linked to invite on our read?
They had it used to be like a button or something.
Step one is figure out how to join.
Yeah, we had a QR code that was working recently, but I don't remember where it was.
Other invite.slack.golangbridge.org. Alright, now that works. We can begin it.
Okay, that's it. That's weird. Yeah, that's it. That's it.
I think I might be in there. I joined the hashtag ATX.
Yeah, that's it. That's one.
Awesome.
That's the CTX. How do you get into Slack to start with?
Yeah.
Awesome. Well, we are close at the end of the meeting. They'll kick us out of here by 9. We gotta do a little bit of cleanup first, but please take home beer and pizza.
No beer, and also, if you parked here, I promise you don't want one of these. It is very expensive if you don't take one of these. It's still $8 with this, but it is a lot more than $8 if you don't take this. Oh, okay.
They don't mean anything. Maybe they do. I don't know.
Yeah, children who like pizza. Please bring a whole pizza. Too much pizza.
Feel free to take the whole one.
Box.
Yeah.
That's fine. Or mix and match slices from different boxes.
Anyone else from last time? The last meeting? We had so much leftover beer. I was down eating cars and I played the tournament last time.
Yeah.
Last was like sleeping on the curb. He's like, oh man, you got anything for sleeping? Yeah, I got a whole thing over here and one. Started loading over here and watched the side for sleeping there. He's like, no man, I'm so water. Water, like, how many water? Oh, there's beer.
Apparently,
We
we
already
have
had
an
this
entire
Didn't have water.
auto testing
Like, how much water? How many
framework
Yeah.
thing.
Especially if they're out on the
Because,
street.
Is this?
Oh,
Oh, which
Whether or not
one?
it goes, but like, kind of start.
Yeah.
Wonderful.
Yeah.
Alright, so it started with, oh, we're just gonna use it internally to be able to automate regression testing on our Google stuff.
Is there a big trash can
A little bit of a bunch of other contractors, and all of a sudden there's this
Oh, like, like, what is it?
schedule compression, and they're like, oh.
Or we can put
no,
it-
you're really gonna really
That one over there.
things you're telling us to do all this. So my boss is like, well, we just need to make it where they can just click a bunch of buttons and record it, and then plug it back, and they don't even have to have a test procedure.
And what?
And I'm like, this is gonna be terrible. It's a nightmare. So, but that's fine, yeah, we're actually, we're actually doing stuff.
No.
It wasn't it,
I was going to,
circumstance.
try to walk somebody else. If you want.
I
already have this, but I could take
Do you know anything is, well, I guess it's not just Linux,
One
but
last process.
using accessibility features to degree testing is like the only way. It's not just like a quick random pixels. And it's like 80% there.
And this is like you actually have control over the GUI that you're.
Yes, you can actually say, hey, give me a tree of all your widgets. Tell me this, what, is this a slider, is this a button, or whatever, and then say, hey, go click that button. Or you can say, tell me whenever this event happens. There's lots of stuff there, but everything kind of doesn't, but not well. And it does stupid things like you can either say,
They don't want you to know this.
session debug, tell me where the accessibility is. Or you can say, hey, do you want to know? Give me this property and tell me where it is. Or you can look at this other environment variable and so it has a different link. There's even this boolean that you
Do you
can
want
set
to
somewhere in
take
the server that
plates and
says,
napkins?
hey, I'm interested in learning some things will say, oh, I know that, some people will say, yeah, we're gonna do it anyway. And so it's good, but
sitting there.
it's been clicking right. But now the fun part is, everything's gonna be running in Kubernetes containers, and so, that's great, now we have to like somehow bridge debug sessions into that hell. What is cluster of nodes? We haven't even gotten there. But yeah, that's what I've been doing.
Yes, yes. The next month will be just resell those terms out and then make the month after. Oh yeah.
It's interesting and horrifying.
Is it all for one?
Holidays always get weird, especially like South by Elephant, one of these holidays.
Yeah, so last year we did, for December, we actually did our meetup, just a casual social thing at Riplo's, at the pizza place. And it was a great spot. And so maybe we'll do that again, because that time of year, this spot is impossible to get into, but that time of year, that spot is really easy to get into. So.
But they don't actually have like any sort of events or a couple packs or like wait until a particular time to have an event.
No, they've got enough. Yeah, that's part of it. Yeah.
We used to run out downstairs here for our parties for Route 7 for like one of the companies.
Yeah.
What does it actually stand for? It's not a graphics tool.
Oh, and I think that they also tend to be a little bit short-staffed that time of year anyways, because people are taking holidays off and everything.
So are they one of those places that expires like
it's
the
ancient.
holidays at the end of the
They're
year?
up to like GTK4 now. And
I'm unclear on exactly how that works, but I know definitely it always seems a little bit sparse as you get